So for the second part, we are to tie a controller and ALU together, but the output of the ALU will feed back into the controller. So here I have my ALU. I have two inputs, A and B, which are 4 bits, a selector for my operand, and a C for my output, which is also 4 bits. So here, if my operand is 1, 0, A and B will add. If my operand is 0, 0, then A and B will subtract. If my operand is 0, 1, then A and B will AND. If my operand is 1, 1, then A and B will OR. So I also have my controller here. I have my clock and my reset as my inputs. I also have C as an input because the output of the ALU will feed back into my FSM. And then I have my operand or select, which is an output, which is 2 bits. So for the behavior of my controller, I have a process for my clock and reset. So when reset is equal to 1, then it will go back to state 0. And if my clock is 1, meaning on the rising edge, then my current state will go to my next state. And as far as my process for my current state and next state, so for example, if I have C to be greater than 5, then it will go to my next state, and so on and so forth for each state. So here at my top level, I take both entities and tie them together. So here I have A and B as my inputs, my clock and my reset as my inputs that both come from my ALU and my controller, and C as my output. And then I have the architecture of my top level where I have both entities as a component. Here's my ALU component and my controller component. Here, I just assign my inputs and outputs to the corresponding entity. So for example, my reset is assigned to reset. My clock is assigned to clock. My select is assigned to my operand select. And temp C is just a placeholder for my output C. And same for my ALU. So here I have my test bench. Named it test bench 2. And then I'm going to take my top level and instantiate it as a component. I also list my inputs and outputs from my top level and set them all equal to 0. And then I instantiate my top level. And then I have a clock process. And I also have a reset process. So here for my simulations, I will go through a couple examples. So for my system, it adds, and if it begins adding, and if the outcome is larger than 5, it will OR. Otherwise, it will subtract and then add. And then it will reset. So here, for example, I have 0, 0, 1 1, which is equivalent to 3, and I have 0 0 1 0, which is equivalent to the number 2. So again, I will add first. 3 plus 2 is 5. 5 in binary is 0 1 0 1. And this is on the rising edge. It's not greater than 5, so otherwise it will subtract. So 0 0 1 1, which is 3, and 0 0 1 0, which is 2. 3 minus 2 is 1. The equivalent of 1 in binary is 0 0 0 1. And then it will AND. 0 0 1 1 3. 0 0 1 0, which is 2. When you AND them, if you get 2 1s, which is here and here, you get a 1. Otherwise, it's 0. So then I have 0 0 1 0 when you AND. Here, my reset is 1, so it go back to the state it began, which is 0 1 0 1. And this is a example of my test bench for my top level for my second part controller with feedback.